Hi guys. So I think we probably can start. So my name is Sasha. I work as software engineer in Criteo, and I really would like to discuss what we are not doing. We will not talk about today, because the name of the speech is pretty wide, and just to give you explanation, what we will not cover. We will not cover any particular machine learning algorithm. We will not talk about any particular framework in details, and we will not talk about any information that you can just Google and get it very quickly. Instead, we are going to discuss real-life examples from the Zapwar field about how do we build our continuous machine learning architecture, how do we use Scala, good and bad sides of Scala, and how did we adapt our development process to more effectively use Scala, and how do we do our machine learning in scale in general. Scala now becomes one of the most principal languages for big data development. When you have a huge amount of data, Scala probably is the best language to express your logic about how do you want to process this data. And there are a lot of benefits and reasons why Scala becomes so popular. Scala is JVM language, and main principal solutions for big data processing is based on JVM. Like Hadoop is Java based, and Java which can fit better. It's not a good solution because it's too boilerplate. You lose in your business logic inside the Java syntax. Cascading, Apache Flink has very nice Scala API. Scaladim is also very good abstractions over Cascading. It's type safe, and it allows you probably one of the best solutions for pure Hadoop development. And Spark is a game changer in big data world, and it's a license to Scala. Here is an example of Hello World Hadoop job in Java. We calculate word counts in the sum text file. It's pretty boilerplate. There are only few places where you actually have business logic, and here is the same code in Scala. There is no unnecessary information, and Scala DSL moves you directly to the business logic, and you operate directly in business logic terminology. Pretty similar Scaldin, the same expressiveness, just to pipe transformation which required by Hadoop specific. Flink, also type safe, everything's fine, easy to use. So Scala is really good solution. Scala is really good solution for big data, rich syntax, type safe API, and actually developing Hadoop job is not very fun. But with Scala, with this power of language, you're always thinking how to express yourself, and even not very motivating job is really nice to work with. So in order to describe our architecture, I need to introduce our business model. In one sentence, Criteo shows advertisement, and we show the right advertisement for the right user in the right time. Simplified model, we have cost per model is price, what should we pay for displaying the banner. We have it's provided by publishers who actually display advertisement. Our partners clients provide us cost per click is the money we win when display is positive, meaning we have sale or click after the display, and we calculate the probability, mathematical expectation of the click of the positive display, and this value is calculated using our machine learning algorithm. In advertisement world, there is the definition of RTB platform. It's a platform like Google who displays advertisement, and there is real-time action in order to choose who will display this advertisement, this banner. RTB platform sends user data to the banner provider. Banner provider processes data, analyzes what can they show to this particular user. There is very small time bound, and when we have garbage collector in this processing, probably we are losing this display. And for example, some guy bid and says that I will show this advertisement for 1 cent. Somebody gives 15, and finally the winner will pay second prize in the action. So our engine machine learning algorithm is trying to answer on 3 main questions. How much can we bid to display this advertisement? What should we show? Which product? And how it should look? How can we optimize look and feel for the banner? The main goal is to make more money for us, for our client, and so on. We have pretty big infrastructure. We have 6 data centers, more than 15K servers around the world, and we have huge big traffic on our infrastructure. We have one of the biggest Hadoop cluster in Europe, which is located in Amsterdam, and we are building even bigger in Paris using CGH5. Actually, we have huge infrastructure in the backend and very few point of connection with the user. We track the user when we show display. We track user on the partner side. We move this data through the Kafka to the HDFS, where we process this data, normalize this data in order to build machine learning models, and we use these models in production when we show display. And in this loop, we are continuously improving our models and adapting to the real world, to the real user, and get new data. Our technological stack. Originally, we were using .NET for online applications. We have one of the biggest .NET deploy in the world, probably after the Microsoft. For offline, we were using Hadoop and Cascading. But now, for new applications, we deploy Scala on Mesos and use Scaldin and Spark for offline processing. Our development environment. Scala is a very specific language and it's pretty rich, so you want to be sure that you have concise development style and your development environment force developers to learn Scala. We use build from source in order to guarantee that all our projects is source compatible. We check out all source code during the periodically from all our Git repositories, build it, ensure that it's stable, run after test, and deploy everything to the Nexus. We use our Maven parent POM in order to achieve the core behavior of this build from source approach, and we developed a custom Maven plugin to verify that to allow build from source happen. Also, we run all after test and integration test during the build from source, and when the test is done, we mostly sure that the deployed artifact to the Nexus is stable, and we are one step aside from the continuous deployment. So we use Maven, and Maven is very bad choice if you want to use Scala, because there is only single Scala Maven plugin which is developed by independent developer and really badly documented. There are no incremental compilation, and when it compiles Scala, in the mixed project, in the mixed model, Java Scala model, it recompiles all Java also. So it dramatically can increase the time of compilation in a huge project. Since Scala has very rich syntax and very powerful abilities, we are using code review. We are using Gerrit to make code review. It's also a very good tool to distribute the same Scala culture inside our company and exchange knowledge of the Scala. Scala has, we are using effective Scala and Scala style guide in order to make our code readable and achieve easy developers migration from one team to another. And but the problem is Gerrit that Web UI doesn't allow you to read Scala because Scala syntax is very rich, and when you read Scala just in the browser, you should have implicit context inside your mind, and sometimes it's really painful, and you want to use IDE in order to verify commit and makes code review. And there is a Gerrit IDEA plugin which makes it happen. So we are using Hadoop mostly for big data processing, and before we start to build our models, we should normalize data. We should normalize our logs in order to have machine learning. There are several problems when you have huge infrastructure, when you have huge amount of data with different types of data. For example, the data which comes, it comes directly from user side, and the first step of Hadoop is to validate data. We learn on huge volume of data, like 35 terabytes each day, and we have a lot of negative events which we want to filter for our machine learning. For example, for 10 displays, we generate only 50 clicks. For 50 clicks, we generate only a single sale. So there are really a lot of displays which we want to filter as soon as possible in order to make our pipeline faster. Also, you want to validate data on the first steps of your big data pipeline. It's also very good time to check fraud detection. For example, you have display and you have 1,000 clicks per one display. It's definitely somebody generates unnecessary click, and you don't want to charge clients for this, and it's improve your performance, and you have less data to process. Also, we are using cascading trap to check all data which wasn't processed by our Hadoop business logic. Another problem that we was using JSON for our data, and it's really crap because in a huge scale you want to understand what's going on with your data and how to get your fields, and it's really can be a problem because data schema mutating, and you don't know how to read it in your jobs. For example, we have display event we generated on the online site. We move this data to HDFS, and we have matching job, which match display and click together. And the output of this job can be some kind of display click, aggregated object, and we use in Protobuf to guarantee that this click in .NET and this click in Scala is the same object. It means when you change schema in protobuf, you need to adapt .NET code and Scala code, and since we are type safe, we have compilation error during the build from source. So it's kind of fail-fast pattern application where we really optimize our development cycle, and we know that our logic is broken. And it's thanks to Scala type safety of Hadoop. So I think really when you build some Hadoop logic, you want to have data safety. You want to have schema for data, because when you don't, it's pretty hard to introduce any schema for schemaless objects. Scaldin TypeSafe API again helps us to detect and verify our business logic, because when we were using JSON, it was like broadcast email to our dev team. We do use this field, can we remove it from our schema? And it's pretty painful, because it means that all developers should verify Hadoop code and understand, do they really use this field? And you know, it's usually when we deploy this field removed, and during the night Hadoop just fails. Also, when you have huge amount of logs on the HDFS, it's a fast system and it's not structured, and it's hard to understand which log is readable and which log is just some trash and doesn't contain any production data. We developed some framework for data discovery, because there is no solution in the market which allows you to get log meta information, data meta information by some identification. So we built abstractions over log format and log partition, how the data is stored and structured inside some folder. It also allows us to share information about schema, since we are using schema for our data. We can store, since we are using schema for our data, we can store schema inside the log definition. Since also we're using Scaldin for data normalization Spark for machine learning processing, we want to make this log definition abstracted and share it between both execution engine. Also, we optimized our development cycle with this framework, and it provides us some schema check. So, log definition contains information where to find the log on the HDFS, what's the format of this data, and what's the schema. It's like kind of table in a database over the file system. Here's the example of the code of the log definition. And in order to have compile time verifications that we have, for example, display inside this log, we must represent this knowledge as in the source code. In order to encapsulate source creation in the Scaldin Spark, we are using type class. For example, here's type class interface, which defines format, partition, and type inside the log. And this type class interface should provide a way to create source for this log descriptor. So we inject these type classes implicit parameter, and it helps us to encapsulate this complexity, and the final API is pretty simple. We just provide log display. We say split discrete for this log, and here is it. And type class really helps to improve dramatically effectiveness of your syntax. as I said, we are framework agnostic. We are trying to have implementation for any format in Spark and Scala environment. Our type class contains this particular framework logic and partition resolution. When you have some particular descriptor, for example, our platform, it's this code is also shared between different execution engines. And also Scala is very nice and has very good DSL. So we stopped to have documentation for our Hadoop job, and we just had a nice BDD and links just directly to the Git repository inside our conference. For example, we document that when we have click, which is late, which is happened after 2 hours and 1 minute after the display, we don't match and we have empty display click. And actually machine learning itself, when we normalize data and we prepare data for machine learning, we start in actual machine learning model building. We have two main use cases. First use case is when new data arrived, we learn new machine learning models. It's business critical calculation, and we have 10 hours to use new data for new machine learning models in production. We have more than 100 different models in our A/B test in the production. And another use case is when some data researcher, data scientist tries to experiment with different features and tries to uses different features for a new model and probably somehow improve the quality. Currently in production we are using logistic regression. Since we have huge amount of data every day, we can just use this one of the simplest algorithms, which is easy to adapt and has very good quality. Since we have a .NET platform, current implementation using Mono on Hadoop, because the function which makes decision is also used in online world, which is implemented in .NET, and we are afraid to have two different implementations for this function. It's very strange combination between Mono and Hadoop, and there is significant issues we have, starting from Mono problems itself, when it's not implemented in some particular part, and when we stop or have some exceptions during the machine learning, we should start everything again, and it takes a lot of time, and again we have only 10 hours to process all data. We are using Hadoop streaming in the mapper. At first we process data. We use recursion in order to emulate loops in logistic regression. We pass data using Zookeeper to coordinate reducers, and we store data locally on the nodes on Hadoop cluster. Currently, this scheme works, but it's very unstable, and the world is moving, and we are considering to use Spark or Flink to improve our machine learning development. Spark is really a game changer, especially for iteration algorithms, when you can express iteration inside your code and you shouldn't make hacks on Hadoop. Memory. Spark uses heavily memory RAM in Hadoop. Memory RAM in order to store data. It's eliminate unnecessary I/O, There is a lot of good initiative like Tanscan project when they optimize the memory usage. They stop to use garbage collector for data. They store data directly in some kind of heap memory. And Spark is a native Scala application. It's very nice to use. Flink is also very promising. There are also good Scala API. It's also designed by design. It's out of memory free. Also, Flink has one of the best stream implementation, because for now in the market there is no web-scale stream processing engines, like Apache Storm doesn't scale for our load. Twitter Heron, which replaced Apache Storm in the Twitter, is not open sourced. Spark streaming is micro-batch adaptation and it's not practical to use also. And only Apache Flink has potential to grow and take this market. Also in Flink there is very nice optimization for delta iterations, which can dramatically improve performance of your machine learning. So conclusions: please use Scala. Please use Scala for big data, and Scala is very good language for machine learning. And please have schema in your data. It helps you to live better. Thank you, guys.
I have a question. Could you describe shortly how you test your code and how you test this particular case?
Okay. So in Hadoop usual development cycle, you write a job, you deploy in Hadoop cluster, you run the job, you look on the job tracker, what's going on. If there is some stack trace, you take your stack trace, you change your code, you deploy, and it's like 15 minutes for single deploy cycle. With Scala, you can mix the same locally, very easy, and it's like normal application. It's like you just run your test, and here is your result. So you can debug everything.
Why Spark streaming is not suitable for your needs?
Actually, Spark is not suitable for our needs for now because we have more than 1,000 nodes on our cluster, and as soon as we know, Spark is not scalable enough to work on such young cluster. But like in 1 year, probably it can be better. Good. For Spark streaming, particularly, there is micro-bashing, which kind of hack, and a lot of experts in the big data world don't believe that it's the right way to make streaming. Okay. Yeah.
Yeah, few questions. First of all, as I see, you have the nearly real-time system, and how do you solve the garbage collection issues?
Yeah, so we're using .NET. When Microsoft made kind of G1 GC implementations, it resolved a lot of issues itself. And when we have full GC because of something, we consider it like a bug. We don't change anything in our heap. We try to don't change anything. And when we have GC, we just lose money. So in .NET, there is no powerful tool to improve, to tune your garbage collector. So yeah, pretty poor situation in this case.
And the other question is, for example, you develop new model. How do you test it before you deploy it to live? So
yeah. When your model is done, the first we have validation phase on the data we had. We know did we have CLI for this case, and new model shouldn't be worse than production one, or should be worse in some normal interval. And after we are starting A/B testing. It's incremental A/B testing. When we have only 2%, for example, of users in A/B test, and we grow up to 15–20% before replacing real model in production. Because it's always probability in machine learning in our models, and it's any features, any code change should be A/B tested, because you cannot validate that you don't break anything. Yeah.
Can you please compare the performance of Scala versus Java code?
It depends, I think, from the style of your Scala. So if it's pure functional Scala, you don't have mutated state. It means your young generation becomes full pretty fast, and you waste CPU on it. When you understand where is your bottleneck, you can use mutate state to improve your performance. Usually, Scala is more than enough for us on Hadoop side, and it works also very good on online also. Like Twitter use Scala for online, and it works. So I believe that Scala is usable for any cases. Okay. Yeah.
So if I wanted to start from scratch doing some simple machine learning, what would be the best stack to start with?
Yeah, I would advise Spark definitely, because when you start, you have several gigabytes of data. Spark is more than fine, and you don't need to use any yarn. Just Spark directly, as is standalone node.
Okay.
And also there are a lot of good solutions from Amazon, from Google Cloud. When you don't have time for your infrastructure, you can just pay for it. Yep.
If you could magically remove all the .NET code and replace it with Scala code, would you do it?
Yeah, definitely. So all new applications Scala for us. Also, one of the reasons because we can tune garbage collector. Yeah.
Do you store all raw data, and in what storage?
Our principal storage is HDFS. It's Google that don't advise to use HDFS for principal storage, but we think that it's replicated 3 times on the normal file system, so it's good enough. And for some non-structured data which should be available in online, probably we are starting to try to use HBase or Couchbase also. Yeah. 1, 2, 3. Okay, thank you very much.